All right, well, the first car we want to work on is a 95 Jetta, and this is a crank no start. Now, this vehicle is in the shop, and it came in for a crank no start, and the first technician went in and looked at spark and fuel, and he threw a compression gauge on the thing, and he said, okay, I got to put a timing belt on here. So that's what he did. Well, once he got done putting the timing belt on, the car still wouldn't start. So now they called in another technician at that shop to take a look at it, and he had a little bit different approach. And what he did was he took his scope and connected it to a pressure transducer, which he attached to a hose, the type that you use for your compression gauge set, and he took the #1 spark plug out and screwed the hose right in the cylinder. And then he took that spark plug wire off from #1 and connected it to a spark tester so he could simulate a spark plug. What this allowed him to do was to take a sync probe and connect it around the plug wire. So now his scope is synchronized to the ignition system, and the screen is going to allow him to look at the actual compression pressures that are occurring in the cylinder. Each time that piston goes to top dead center, it's going to create pressure. Each time it goes down to the bottom, you're going to see the pressure drop off. It's going to go through all 4 strokes, and then it's going to repeat the compression stroke again. So on the next screen, we're going to see what that looks like on a scope. In this case, this technician used the ATS E-scope, and it's a very powerful tool, and it's got a lot of this software that helps with the diagnosis of cylinder pressure problems. So let's zoom in on the waveform that this fellow acquired. The first thing I'd like to point out is that what you're seeing here with this yellow peak, and I'm going to draw an arrow going up, that's the piston going up on top dead center. Then once the piston gets to top dead center, it travels back down, and what we see is the pressure in the cylinder depressurizing because the piston's going down. And then at the bottom of that, we see the valve open, the exhaust valve. Right here in the middle, but there's even though there's an event happening, we don't see it because the exhaust valve's open. So at this point, the piston is going back up on top dead center on exhaust. So the piston pushes the gases out of the cylinder, and then it comes back down on intake, and finally goes back up on compression right here. So what I want to point out to you is these purple lines represent a grid that is 360 degrees. And this gives us a chance to look at the full rotation of the crankshaft. Now, the point I wanted to make here is, if you'll notice, we've got 2 ignition events called out. And so that is, waveform is coming from our sync probe. Our sync probe is representing when the #1 spark plug fires. Now, it doesn't take too much to realize that something's wrong here. The ignition event should really be happening at about top dead center, which would be represented here by this grid line. In fact, our ignition event is significantly retarded from top dead center. Now, this represents a problem, and even though the fellow that put the timing belt on did his best to align the belt, clearly something is out of whack because our ignition is not occurring at the proper time. Now, of course, the technician had to kind of talk the other guy into taking the cover back off because the guy was certain that he'd done it right, and but he had some pretty good evidence here that that this timing was off. Well, when they looked at the marks lined up, but the technician said, what we're going to have to do is, the one thing that we haven't considered is the relationship of the crankshaft pulley to the crankshaft itself. So even though we have our dot on the crankshaft pulley and our dot on the cam pulleys lined up, we don't know for sure if that bottom pulley is correct in relation to the crankshaft. And since we have really solid evidence that we have a mistiming problem, we can feel pretty confident that if we remove that pulley, we're going to find a problem. Well, sure enough, the pulley is removed, and the key, or what was supposed to be the key, is rusted out and spun, and the pulley has shifted on the crankshaft snout. So at this point, this engine is out of time, even though all the timing marks are okay. So this is a difficult diagnosis, and just using the conventional tools, the technician knew at the beginning he had a compression problem, but he put a timing belt on there, lined everything up, and he still had the same problem. And with the addition of this tool, we can really see evidence that will allow us to know that we've got to go into the engine deeper. So this is just one example of how this setup can be used to diagnose an engine mechanical problem.